Dr. Romano, professor of organic chemistry here at Romano Scientific in New York and the creator of the DAT Destroyer book and the Orgo-Man products. I am here today with Professor Louis Blois, who is a mathematician, and he was a great contributor to the DAT Destroyer books. I want you to take a look at the question he has for us on probability. It's sure to gonna amaze you.
Hi, yes, here we are. This is the subject of probability, and we're going to focus on the principle of complementarity. Notice how it's spelled, complementarity, with an E over here. And basically, it's the probability of event A added to the probability of not event A is equal to 1. In other words, if there's a 60% chance of rain, what's the percent chance that it's not going to rain? It's going to be 40%, whatever is the complement of 100%. Okay. Let's do a couple of problems involving this principle. If the probability of an event occurring is A over 20, and the probability of that event not occurring is 1/4, what is the value of A? Okay, well, we're going to use the same principle here. The probability of A plus the probability of the complement of A is equal to 1. So the probability of the event occurring is A over 20. The probability of the event not occurring is 1/4. That equals 1. We're going to subtract 1/4 from both sides of the equation. A over 20 is equal to 1 minus 1/4, as we can do that in our heads, is 3/4. 3/4. Multiply both sides by 20, and we're going to get, the 20s cancel out, 4 goes into 25 times. 5 times 3 is 15. The value of A is 15, principle of complementarity. Now, let's do a slightly more complicated question, and to see how the principle of complementarity can save us a lot of calculation in certain instances. A bag contains 3 orange tiles, 3 red tiles, and 3 blue tiles. 3 tiles are drawn simultaneously. Find the probability of randomly drawing at least 1 orange tile. First of all, when 3 tiles are drawn simultaneously, how is this modeled? Traditionally, the way it's modeled, the standard way of modeling it, is to model it as if the tiles were being taken out sequentially without replacement. Okay, that's how it's going to be done. All right, the probability of randomly drawing at least 1 orange tile. So that means we need to do this. We need to the probability of drawing 1 orange tile, plus the probability of drawing 2 orange tiles, plus the probability of drawing 3 orange tiles. That's what we're looking for. And now, without the principle of complementarity, we would have these 3 computations to evaluate. However, we know that what's the only outcome that's missing from this? 1 orange tile, 2 orange tiles, 3 orange tiles. The only possibility that's missing out of those 3 chosen tiles is 0 orange tiles. So if I add that to the probability here, probability of 0 or 1 or 2 or 3, well, it's a certainty that one of those is going to be the outcome, so that those probabilities all add up to 1. So what we're looking for is the probability of randomly drawing at least 1 orange tile. We're looking for the value of this expression. What if we subtract P, probability of 0 orange tiles, from both sides of the equation? Then we're going to get 1 minus the probability of getting 0 orange tiles. So look at the expression on the right. We only really have 1 probability computation to perform. Subtract it from 1, and we will get the answer. So now let's go to the side and find out what is the probability of getting 0 orange tiles. Well, out of the 10, what are they? 3, 6, 9. There are 9 tiles in the bag. And what is the probability of getting 0 orange tiles? Well, 3 are red and 3 are blue, so the probability of getting 0 orange tiles is a 6 out of 9. And we want also after that is taken out, the next event is to pick another non-orange tile. Well, there are only 5 non-orange tiles left and 8 tiles in the bag. And for the final choice, we only have 4 tiles in the bag that are not orange, and a total of only 7 tiles in the bag. So the probability of getting 0 orange tiles is this. So let's see, let's simplify this. 4 goes into 8 twice, and 2 goes into 6 3 times, and 3 goes into that, 3 goes into 9 3 times, and what do we have here? 5 over 21. Okay, multiplying across the numerators, then multiplying across the denominators. Back to our main problem here. What's the probability of drawing at least of at least one orange tile? It's 1 minus the probability of drawing no orange tiles in those 3. So it's 1 minus 5 over 21, which is equal to what? 21 over 21 minus 5 over 21, and that's going to be 16 over 21, and that's the answer to our question. That's the probability of drawing at least one orange tile in a draw of 3 tiles.
Excellent problem. Wow, that was absolutely smoking.
Oh,
Wow.
great.
All right, I hope you enjoyed that. It doesn't get any better than Professor Blois. All right, for more of Professor Blois' work, see the Math Destroyer book. Okay, good day to you. Bye-bye.
Bye-bye.